Good morning, everyone. Thank you for choosing our session. So today we are going to share with you the work we have done around a cross-reference code mapping system, and this has to do with medical products. The idea is to dynamically map medical products across terminologies and the regulatory framework. So this is our agenda for today. Let's go ahead. Thank you. So about myself, I am Ismaël Hassane. I'm an open source specialist at Oracle. So on a daily basis, what we do is to help our customers, let's say, onboard on open source technologies. A bit more about myself. I have about 10 years of experience with data platforms. And for a very long time, I was more on the other side with proprietary technologies. But about a year ago, I have switched to support only open source technologies. That's for me.
Hi, everyone. I'm Irene. I'm also part of the open source specialist team with Ismaël. And this is actually my 8th month at Oracle, and I'm super excited to be here.
Great. Next one. Great. So a bit more about Oracle in general. So to us, open source definitely matters, and we contribute in various ways. There are projects that we lead, some others to which we contribute, and that one include Opensearch, of course, and we participate also in the various boards and technical committees. So next one. So about the two of us, we support other technologies, not only Opensearch, but mainly in the database area. You will find the relational database technologies, non-SQL technologies, and also the caching system. And of course, you have seen Opensearch in here. Next one. And apart from that, we also have data processing tools that we support for our customers and across EMEA. Great. So this is it for the introduction. Now we're going to focus on why you have selected this session. So first of all, before we get started, I have a quick question for you. It has nothing to do with IT, so it's fine to be wrong. Who in the room is aware of what is Paracetamol? Please raise your hand. Thank you. What about Doliprane? Only one person. OK, great. What about Acetaminophen? Aha, perfect. So as you can see, not the same people raised their hand for the same questions, so this will definitely make sense in a few seconds. I will try to explain why. To come back to the agenda today, so first of all, we're trying to really explain the challenge in more details, and it will have to do with the way you have been answering these questions I had. And then second, we will try to understand this medical data, specifically in the pharmaceutical industry, understand the data, and move on to the solution part, where we are going to try to focus on mapping these products across borders and across regulatory frameworks. And then we will present the architecture we have selected. And in this architecture, it has some specificities. And again, it will have to do with the distributed nature of the regulation of pharmaceutical products. And also, we'll focus on the fact that local expertise definitely matters. And at the end, it's important to serve everyone. And on another point, we will present a quick demo we have done. So the idea, again, is to show how accessible the technology is, for instance, Opensearch. So far, during this whole Opensearch concession, we have seen how the community has been really pushing the boundaries of the technology. For this session, we will see how the technology will be used to push boundaries, period. And finally, we will discuss the benefit of this approach, and also the fact that it's a cheaper approach, mainly because it's an open source technology.
OK, so let's try to capture the feeling of the challenge we're trying to solve. So ruined vacations. Lake Como shimmers. Red skin burns, a tourist sighs, cream left far behind. Bellagio's beauty lost to relentless itch, no joy to the view. He runs to the pharmacy, dermatitis relief now. Opensearch might know. A desperate hope blooms for soothing balm, a cool touch, an escape from the fire.
Great. So you might have guessed it. Today, Opensearch is the technology that's going to save the day. And yeah, let's go. Let's move on. So our tourist that was obviously not enjoying the view of Bellagio. I don't know if there is any Italian here or someone who is familiar with that place. It's a very beautiful place. You have a nice lake in there, but he was not enjoying it just because he has a chronic disease, and he forgot his medication back home. So the medication he's used to is the one you have on the left. So I'm going to skip the name. And then what he got when he got to the pharmacy was the other one on the right-hand side of the screen. So what happened? The pharmacist did not have the medication he is used to have. So again, for this medication, you don't necessarily need a prescription to buy it at the pharmacy. But the pharmacist was able to offer him the alternative. And again, spoiler alert, it definitely worked. It helped him. It saved his vacations. And he was able to go back and enjoy the view of this beautiful lake and the village of Bellagio. So next one, please. Thank you. So again, because we are curious, we have a few questions we're trying to understand. First of all, why did the pharmacy did not have this exact same medicine our tourist is used to? So naively, we can think it's about availability. So maybe just this pharmacy was doing a poor management of its inventory, and the medicine that our tourists need was not available. So first one, we will assume that they are doing a good job in there, and that it's not the case of availability. On the second point, it has probably to do with the regulatory framework. So again, because we are in a highly regulated industry, the regulation plays an important role, and it will definitely impact the availability of a specific medicine that's available in a specific location. So about the regulators, usually let's say the main regulator, the ultimate one, will be at the national level. So if you consider Europe, all of the countries have their national regulators, even if at some point at the European level there are, let's say, some competencies that they share. For some specific medication, they share the competencies, and then the decision is made at the European level. But then again, ultimately, the national regulator is the one which is in charge of approving or specifying how a certain drug will be used. And again, if we go overseas, the regulator for the USA, for example, will be the FDA. It's the Federal Drugs Administration. So again, these regulators, they enforce let's say, the amount of, or the specific medication that's available in a specific pharmacy, and they are let's say, the end boss, if we can call them like that. And finally, we have this notion of anatomical therapeutic chemical, which is a classification system which is first designed and maintained by the World Health Organization, which will allow to basically understand for a specific drug which part of the body it's targeting, and which basically with what it's helping. So if two drugs have the same ATC code, usually, you're fairly, let's say, certain that you can use the same drug, and then it's going to solve your issue. So to go back to our tourist, probably the decision process is the following. So first of all, you compare, you try to have the exact same drug, and these drugs will have a commercial name, so it was not available. So that's the first stage. Then we move to the active substances. And about the active substances, if you have the same active substances and in the same amounts, you're fairly sure that it's basically the same drug, and we can call them even generics. And this has cost implications as well. And finally, you have the ATC code. So as I have mentioned, same ATC code, it means you're probably solving the same issue. So to come back to these two drugs, they don't have the same name, they don't have the same active substances, but they have the same ATC code. So you're able to serve your customer or your patient that's in your pharmacy. And again, so this is the first one we're trying to solve, obviously. And then the second point is that if you have a system where you can map across these products, you will be able to support your medical professionals. And this, again, across the globe. So, for example, if I take example with IT, in general, it's universal, right? What works in Amsterdam will probably work in the US. But when it comes to medical support, because of various regulation, the borders might play a role. And the idea here is to make sure that you can go from one place to the other. So it will foster innovation. And then on the third point, since we're trying to solve this problem at scale, how are we going to be able to do that? So first point, it's important to have a nice or a very good understanding of the data. And then on the second point, be very careful, because these are medical products. So if you make a mistake, it can cost lives. So we will have to be careful, and even this will have an impact on the technologies we will choose, because again, our overall goal will be to always fall back on the recommendation of the regulator. Next one, please. Thank you. So the status. Our tourist had help when he got to the pharmacy. But how was this done? So to understand a bit more the system, the current system. So if you go in a pharmacy, typically they will have a pharmacy management system. And this system, it comes with various modules. So the first one is inventory management, for example. So we will assume that this one did its job perfectly well. And it's not a question of availability. On another point, we have the point of sale. So these PMS systems also manage the point of sales and the billing, and also an understanding of the patients. So to understand the demographics in the place where you have your pharmacy and basically your patients, it will help you to manage this inventory and also know what drug you have to order, how to prescribe them, and so on. And then finally, we have the prescription management. So in this module, that's where it's important to have a system where you're able to have the equivalence of various drugs, to be able to search, check the contraindication, the interactions, the dosage, the administration, and also make sure that you have accurate dispensing and labeling. So if we go back on this search equivalent, there are providers who are maintaining those databases to make sure that you have an up-to-date and accurate information. So in that area, there are usually two types of groups. So the first one, we have commercial providers, and then on the second point, we have open source providers. So that was great news for me. And in that, let's say, in that group of open source providers, we have obviously the regulators, because their goal is to make sure that there is awareness and all the information they put at our disposition is accessible and reaching the citizens. So in that, we have the EMA, the European Medicines Agency. We have the FDA, for an example. And also, we have this one, Drug Bank. And that one is open source. I was really happy to discover it. And so that one will be our inspiration, and we will try to see how we can do something similar with Opensearch. So if we consider, let's say, another technology that might be an option. So if we go with the route of a relational database management system, for example, and considering the data that we're retrieving from the regulators, if we try to map that, modelize or design this data model, it will look like something like this. So very complex, not easy to implement, to maintain, and basically to feed. So we'll try to avoid that approach. So again, I have 2 points about our requirement for the system we're trying to build. The first one is that it's important to have a distributed let's say, distributed the maintenance of this whole system, because the data that will be needed here in Europe is not exactly the same that will be needed in USA, for example. And in that sense, the local expertise is very important. So in the system that we will try to build, we will try to reflect all of this. So the first one, if we consider Europe, for example, we will try to deploy a cluster where we will have all of the European data. And again, in Europe, we have 2 stages, the national regulators and the EMA. So we'll try to have all of this data in the European cluster. And again, to go back to our tourist, it's important for us to have access to data from other locations. So for example, if you consider the USA, and assuming our tourist is American, he's in Bellagio, but that pharmacy needs access to the data that is made available by the FDA. So in that sense, we will need a way to access the cluster that's remote. Next one, please. Thank you. So to build this system on the conceptual point, so we will have various data sources. The data will not necessarily be the same. We will need a tool to extract and load the data. We will need to make sure that we have a way to index this data, because at the end, the goal is to run search on this data, access the data, and then respond to the medical professional. Next one. So the solution we have come up with to make sure that it reflects and captures all of these requirements is the following. So on the lower hand side, on the left of this diagram, you have the trusted sources. So we will really try to capture the data at its source and these sources that we trust. So in here we have the EMA, the ANSM, that's the regulator for France. So probably the one who knew the Doliprane is aware of this one. And then we have the FAMHP, which is from Belgium. And then if we move on the second point, in here, for the purpose of this presentation, we will capture the data, store it in a staging area. That will be an object storage. And then we will process that data with Data Prepper, again, so the community's contribution, store that data into the Opensearch database, and then transform the data to make sure that We preserve, first of all, the local specificities of this data, because if you assume that you have a pharmacy in Belgium, for example, it's important to them to have 100% of the recommendations of the regulator, so 2 steps. Have the data as it has been produced, and then make sure that we kind of synthesize the data so that we can create bridges across the various regional, let's say, regulation. And yeah, so in the case of the remote access to the data, again, we will want to access the cluster. For example, if you assume that on the FDA side, they have their own cluster where we might find the Canadian data also as well. Then we will need a way to access this data. And again, you will find that Opensearch is an incredible technology, and it will allow us to have access to this data with the cross-cluster search or the replication. So great news for us, Opensearch is going to do the job, and again, we will be able to push boundaries with Opensearch. Next one, please. So yeah.
Okay. So now let's get into the demo. So first, we will talk about the workflow that we have designed for our use case. So first, we are creating 2 Opensearch clusters using OCI Opensearch. And then we will be cleaning and processing our data. And we'll be sending the Europe data to the Europe cluster and the US data to the US cluster. And for the Europe data, we will be combining all of the data into one index so that it can be used for keyword search. And for the US data, we will be filtering and processing and keeping only the relevant fields so that we can create vector embeddings using the model that is mentioned here. And then once this is done, we will be creating a cross-cluster connection so that we can do a cross-cluster search. And finally, we have built a Streamlit application on the Oracle Cloud Infrastructure virtual machine, and we'll be performing our searches. So now let's get into the demo. So this is our Oracle Cloud Infrastructure console, and here, oh, sorry.
And here currently we are
Yeah, and here on the right, we can see the region that we are currently in. We can select whichever region where our data resides and where we would like to create our resources. So here, we're going to keep it as it is. Yeah. Next, we will be going into our navigation menu, clicking on Databases, and click on Clusters under Opensearch. And these are fully managed Opensearch clusters on OCI. So we've created 2 clusters here, one for the Europe data, which is the first one, coordinating cluster OSCON. And to create a cluster, we can just click on the Create Cluster button, give it a name, select the compartment where we would like to keep our cluster in. So a compartment basically is a logical container to organize our resources in OCI. And next, we can select the software version. So currently, the latest version we have of OCI Opensearch is 2.18. And after that, we can give a username and a password for our cluster. And once this is done, we can configure our nodes. So here we can add the number of data nodes, and we can add the OCPU count, the memory, the storage for the data nodes, for the leader nodes, and also for the Opensearch dashboard nodes. Here we can either manually add this, or there are node optimization profiles, which we can select on the top. And after that, we will be selecting the network where we would like our cluster to reside in. And here we're giving a private subnet. And finally, we can see all of the configurations that we have added for our cluster. So here now, we will be looking at the Europe cluster that we had created. So this coordinating cluster OSCON. So here we can see that we have the cluster details, we have the network details, and one thing to note is that we only get a private IP for both the cluster and also the Opensearch dashboard. And on the left side, we can see different resources here. So the first one is metrics, where we can see different kinds of metrics for our OCI Opensearch cluster. And then we can also get automated snapshot backups of our cluster. And this is taken daily, but this can also be scheduled according to our needs. And next, we have added a cross-cluster connection. So the Euro cluster is the source cluster, and we will be searching for our indices from the US cluster, which is a remote cluster. And to do this, we need to create a cross-cluster connection. So I had added a connection. We just need to add the alias for our USA cluster, add the type, which is outbound. The mode will be search only, since we'll be only searching for the medicines. And we have to also add the cluster OCID, which is basically a unique identifier in OCI for every resource. And here, this is our USA cluster. And here, we can retrieve the OCID from the cluster details. So finally, another resource that we had used were pipelines. So we had used data prepper pipelines to process and ingest our data. So to create a pipeline, just click on the Create button, give the pipeline a name, select the compartment. And here, for the source type, we can either use object storage or Kafka. So in our use case, we had used object storage, which is basically a storage service provided by OCI. And here, we've dumped either CSV data or JSON data, and we're processing and ingesting it into our clusters. We can also use Kafka to stream data into our clusters. So once this is done, we need to generate the YAML, the pipeline YAML. And here, we will be adding the cluster username, the password, and we can also add the type of data we're ingesting. So it can either be new line, it can be CSV, it can be JSON. And also, we will be adding the object storage bucket name, the region, and the namespace. And finally, we will be adding the cluster OCID, where we will be sending our data, and also the index name, where we will be indexing it. So other than this, we need to also add the source coordination YAML, which is basically another object storage bucket which will track the progress of the data that is being sent to our clusters. And finally, we can add the hardware configurations. So we can add the node count, the memory, and also the OCPUs. So now let's look at the ingest pipeline, the data prepper pipeline I created for Austria. So just click on More Actions, View YAML. And here you can see that we have used the OCI Vault service, which is basically it's a service provided by OCI, which helps us manage and encrypt keys. And here we've added our OCI Opensearch username and the password. And the type of data we will be ingesting for Austria is CSV. And we have also scheduled this data prepper pipeline to work every 40 seconds, as you can see there. And we've also added the bucket details. And we've also used a processor for date. So we're basically converting the a date field from our CSV into a proper format. And finally, we will be adding the cluster details, the cluster OCID, and also the index name. So now let's look at the object storage buckets and how the data is ingested. So this is our USA bucket. And here you can see that we've just dumped JSON files, which will be processed and ingested into our index. And similarly, for the Austria dataset, we created another bucket where it's just a CSV file, which is also being processed and ingested. So now that we've seen how we can create a cluster, create pipelines, and we've looked into the buckets, let's go into our Streamlit application. So for our application, we've created a very simple application where we will be doing keyword search for our Europe data and semantic search for our US data. So here I'm going to type in paracetamol as a keyword. And you can see that about 100 results have been queried. And here, if either the active substance or if the medicine name has paracetamol in it, then the medicines are retrieved. So we can get the ATC code, the active substance, the medicine name, the authorization code of Austria medicines, Austria or Belgium medicines, and the manufacturer name, and also the country, and the status, whether if it's available or not. And we can also add a country filter to only retrieve medicines from a specific country. OK, now let's go into semantic search in the US index. So here we're using the Distel-Roberta model, which is basically a generic model. And we will be creating vector embeddings in in our index, and also the same the query will also be we will also be creating vector embeddings for our query with the same embedding model. So this is our Opensearch dashboards. This is how our final USA index looks like with all of the relevant fields, and also the search vector with vector embeddings that are 768 dimensions. OK, now I typed out a medical need, which is pain relief medicines, which would also help for fevers. And we have retrieved about 20 similar results if either the indications in usage or if the purpose has the medical need that was typed out. So here you can see that most of the medicines that have been retrieved either have ibuprofen or acetaminophen in it. And we can also retrieve the NDC authorization codes, which are the regulatory codes in the US. Here we have also mapped the RxUI codes to the ATC codes, which I'll talk about later. But with the ATC codes, we can do a keyword search in our Europe data. So that's what we'll do now. So we're selecting an ATC code from here. And we'll do a keyword search for that. So here you can see that paracetamol is the medicine that is mainly being retrieved, and it is a medicine that is used for pain relief. So yeah, this is how our application looks like. And one thing to note is that our source cluster is the Europe cluster, and we're basically just searching our index, our US index, because of the cross-cluster connection we've created. So now, let's go back to our presentation. OK, it works. OK. So now let's talk about the data model. So this is for our Europe cluster, our source cluster. So we have gotten 2 data sets for Austria and Belgium from their national registries, and we have combined this data into a single index while maintaining the raw data. And this will help us to do keyword search in a more simpler way. OK. So this is how we had created our base query. So here we can see that we can do a keyword search with either the active substance, the ATC code, or the medicine name. And we've also added a boosting factor for each of these fields. So with medicine name with the highest priority, next the active substance, and then the ATC code. And we've also added a wildcard filter for our ATC codes. And the reason for this is because we're doing a keyword search from the US data, US index to the Europe index with an ATC4 code, even though our Europe data only has ATC5 codes. So with the wildcard filter, we're able to do this. And finally, we have also added a filter by country. So this is the data model that we had used for our US data. So the data is from the OpenFDA website, and we have processed and filtered the data to only keep the documents with the field OpenFDA, because the field OpenFDA has multiple subfields that are very relevant for us, like the brand name or the generic name. So we've made sure that this field exists. So this is the semantic search workflow that we have proposed. So in the beginning, we had about 180 documents in our index. And once we've filtered to keep only data with the OpenFDA field, we had about 64,000 documents. And then we created an ingest pipeline to combine a few of the relevant fields to create the vector embeddings. And we were able to generate the vector embeddings from a selected model. And finally, when a user inputs a query, the query is also converted into a vector embedding using the same model, and we perform a KNN search. So on the left, you can see that this is how we had created the field. So here we combined 3 or 4 relevant fields that would help us with creating the vector embeddings. And on the right, you can see this is the mapping we had added for our final index. And we had used the space type as cosine similarity, because since we don't care about the length of the sentence rather than the underlying meaning, we have gone with cosine similarity rather than Euclidean distance. Yeah. So finally, we had tried out 2 models. One was a general purpose model named Distal Roberta, and this is trained on general text. And we had also tried out a biomedical model named SAPBIRD, and this was trained on medical ontologies like the Unified Medical Language System. And this model is great for linking terms like the RxUI codes or the ATC codes, but in the end, we went for the generic model, and this is because we wanted to create customer-style queries, like, for example, pain relief medicines or medicines for heartburn. So in the end, we went with this model. And finally, we had done a mapping between the RxUI codes and the ATC4 codes. And this was done using the API, with this API. And an RxUI code is basically a code provided by the National Library of Medicine by the US. And this is used for drug classifications, while the ATC code is provided by the World Health Organization. And with the help of this API, we were able to do a mapping and basically search between our US and Europe data. So yeah, now Ismaël will talk about the benefits.
Thank you. So as you have seen, our initial challenge was complex, but again, it was not on the technology front. And with the great work that the community has been doing, we can take something as complex, something that can save lives, and really do it quite fast. You have seen deploying the Opensearch cluster was very easy. Connecting to remote clusters was really easy. And these have, let's say, practical use cases. So again, the first one is that you will be able to streamline research. So all of these professionals working on that field will be able to, to have a tool that's easy, where they can convert things, they can contribute locally, but also have a global impact. The data is interoperable in the sense that we found the mapping mechanism to go from one area to the other. And finally, Opensearch is really standing out. So the very fact that the technology is not a problem is a success in its end. And thanks to the community's great work, we have an end-to-end platform. So this is, I would say, just one of the use cases of Opensearch. And there are a lot more. And so we have a data processing, storage, the search, the cluster search, and the replication. the global access of the data, and especially if you leverage a cloud provider, then you have access to all of these data centers. And finally, these cloud service providers have also compliance. So this specific pharmacy can even trust Opensearch to store even more data that's sensible because they have this security in terms of compliance. We have built-in automation, and then the cost is predictable, mainly because you don't have to pay licensing fees. And let's say the biggest value added, or the cost, let's say that is supposed to be the most expensive, is the human input. And the same way as the community has been contributing, our aim for this application is to really continue building it and opening it for the wider community. So you have seen we have published everything in here. And again, the most difficult part will be for the regions which are not as connected as Europe or USA with the FDA and so on. I have been, by curiosity, searching in a specific location. They have a website, but that have not been updated for the past 2 years, and there was no data. But again, there is a kind of a silver lining in there, because instead of having, from country to data that they share to their citizens or to the other health organizations, it's more of a top-down approach where they trust the World Health Organizations, for example, to establish a list of essential products. So we will have to really have a creative ways to make sure that everybody is represented in this system, and also keep the same spirit, make sure it's open and accessible to everyone. So thank you very much. If you have any feedback, any input, we will be really happy to integrate it and keep the same Opensearch spirit into this tool, which we believe is going to help lots of people around the world. Thank you very much.
I think we have time for one quick question. If we've got one quick question, and then we can do the rest outside. Thank you.
Yeah, it was really cool to see how you're using Opensearch for practical reasons. And I had a question related to your performance benchmarking strategies. I'm sure accuracy and speed is really important, more so on the accuracy because it can cost people's lives. So what strategies do you have right now for benchmarking, and do you wish there are any things that you can improve about that strategy?
Yeah, so first of all, as you said, mistakes can cost life. So what we have done is to make sure that in the result we show, it's exactly as the regulator has recommended. So in that search result, you will find all of the specifications, so the contraindication, how you should use it, and so on. And again, it's true that in the models we have chosen something that will be a bit more generic, accessible, but we trust that because the pharmaceutical products will be in a pharmacy, so there will be a medical professional, between this tool and probably the end user, or at least between the end user and the pharmaceutical product. So the idea is that the data will be, let's say, read by someone who knows what he's reading. And so that's also another line of, let's say, security that we believe we'll have. Otherwise, on the technical point, yeah, can we have a comment, maybe?
I guess at least for keyword search, since we're using active substances and the ATC codes, so whenever two medicines have the same active substance and ATC codes, they are the same medicine. It's just a different manufacturer. So this is one way we've tried to, especially by giving a boosting factor for these relevant fields, we've tried to make sure that the medicine that's being retrieved is as similar as another one. Yeah.
Okay. All right. Thank you very much. Really appreciate it.
Yeah. Thank you.
Any other questions, please? Yeah, I'm sure that they will take those questions outside.
Yeah.
All right. Next
Thank
session
you.
in about
Thank you.
2 minutes.